and I felt really bad because it legitimately, if they're listening with headphones, it probably did hurt their ears because I just switched to the camera and went, roar, like screamed at it. Anyway, we were talking about 2.5 yesterday, and we were completing the square. So yesterday, we worked through a few of these, and before I just scroll down, how could I look at any of these problems and know the number that I'm supposed to fill in? Like, how were we able to work out that it was a 4 here, or a 16, or an 81, or a 49/4? So you say divide by 2, and I agree with you, and this is just for thinking purposes. What gets divided by 2? The b, right? The value, the coefficient of that second term, or your linear term, however you want to word it. Now, as we kick through, yesterday we ended with just this slight rule. We can always find the c by taking b, dividing it by 2, and squaring it. Okay, we are going to see this implemented in a few different ways. We spoke about the significance of why we would possibly want this. It's easy to graph here, hard to graph here. But it turns out that if you absolutely hate factoring, there is another workaround. It is still going to require you to factor, but it makes stuff nicer. And eventually, we're going to get to the quadratic formula, which I think you guys have seen. Does that sound familiar? Negative b plus or minus the square root of blah, blah, blah. We'll get it. If, like, you might have seen it in Algebra 1, we're going to do more than see it in here. But let's jump in and let's start looking at some problems. So we have our generalized rule, and we're going to do a couple together because it's going to feel odd the first time. As long as we have an equation, if I do something to the left side or the right side, doesn't matter. Am I allowed to do something as long as I do it to both sides of it? Yes, that, bless you, is our kind of important part that we're going to use here. So we are going to solve equations by completing the square. Instead of writing completing the square, I'm open to a suggested shorthand. Anybody have a suggested shorthand for completing the square? CTS? CTS? Completing the square, or CT square maybe, if we just do this. I don't know. You can use your notation, CT square, CTS, complete, like, I would pick up what you're writing like 90% of the time. Okay, so let's check one out here. And there's a couple different approaches that we can use, and we're really doing the same thing, but let's roll through. So I want us to solve the following wonderful equation. And we'll just start with a nice one. Let's say I want x squared plus 3x plus 5 equals 0. And this problem's nice because immediately it's going to let us recognize why we might need a new method. So right now, we're trying to solve this. Normally, we use our F word, which is factor. So let's run through the list. First thing I always check, Seabass, we made eye contact. Is there a greatest common factor between these three things? No. Okay. What's the next thing we always check? Natalia, is that a binomial? Well, shucks. All right. The good news, Angel, is it's a what? Trinomial. So we're going to check a few things. Now, whether you check for grouping first or perfect square, like, it's entirely up to you. The order doesn't really matter as long as you're doing something that works. Let's check for perfect square first. Do you guys know the square root of x squared? Yeah, it's x. What's the square root of 5? Okay, bummer. 2 point. Ugh. Okay, so that's not going to work. Not a perfect square. But what's the leading coefficient? So maybe we can group it, right? Like, there's a shortcut, maybe. What would I do if I'm trying to factor by grouping? How do we begin this process? That's open to everybody. Multiply. So 1 times 5 is 5. Give me 2 factors of 5 that add up to 3. So that's -6 if you multiply them. But I agree. 1 and 5 doesn't work. 5 and 1 doesn't work. Do we recognize at this point that maybe all of the factoring techniques that we've had thus far just isn't sufficient? Like, it's not enough for us to do this, right? So I'm stuck, right? We just give it up, say we can't do it, and that's the end of the story. That better not be what we do. There's very few things in your life that I would say you fail once and you just give up on it. That's a terrible way to live your life. You're never going to be good at anything if that's what you do every time. So the good news is I think we have another method. And I hope that you guys can see that we have another method. How are we going to solve this? We're going to try one more time. How do you think we might solve this? Oh my gosh, I bet we can complete a square somewhere. Now, there's two trains of thought that one could take. First thing, this is not a perfect square trinomial, but we can probably make it such. So, two options, and we're going to do the first one way, we'll do the second one another way, and we're really doing the same thing, but Michael's suggestion is what I'm going to roll with. If you didn't hear what Michael said, he said subtract 5. Now, I'm going to leave an awkward gap right here, and I'm doing this for a very specific reason. I want you to leave that awkward gap as well. Now, what I'm going to attempt to do is whatever's on the left side of this equation right now, I want it to be a perfect square trinomial, and we have a way to make that happen. Can you guys tell me what is the value of b in this ax squared plus bx expression? 3. So I will annotate more than maybe everybody needs. It is entirely up to you how much you write down when we annotate stuff. But check it out. I'm going to make a little note. We'll say, let's complete the square. Let's complete the square. And I would use a shorthand that you have worked out if I were you. But we're going to be more specific. Let's complete the square by adding something to both sides. Now, I'm not going to write the word something. That's a silly thing to write down. If you want to complete the square, you take that b term and do what to it? Divided by 2. So let's look at this. I'm going to take b right here. It's 3. I'm going to divide it by 2. I'm going to do what to it? Squared. Now, your fraction stuff. If you are, this class always surprises me because you guys claim you prefer fractions more than decimals, which maybe I've shown you the light. How do you square a fraction? Square the top and the bottom. So I'm going to add 3/2 squared, but there's a better way to write that. 9/4. Which side of the equation should I add this to? So I'm going to add 9/4 to this equation. I better do it to both sides. And just in case people get goofed up, because this mistake is fairly common as we run through Algebra 2 and pre-calc and stuff, both sides, when I say that, I think this next part is implied, but I should probably be more clear with it all the time. Both sides of what? Both sides of the equation or the equal sign. Okay, now, in this, if you want it to be another line, I'm fine with that. If you just want to fill it in here, I'm cool with that. But I'm going to do what we just said. I'm going to add something to both sides. What was the something we agreed we would add? So here we go. I'm going to make this one stand out. I'm going to add a 9/4 right here on the left side, and I'm going to add a 9/4 here to the right side of the equal sign. Have we cheated anywhere? Did we break any of the rules? No, we're just using the additive property of equality as a really formal name, but we're just adding to both sides. Now, there is a huge benefit to this. This whole process, that deciding what we add, does everything that I need it to. Do we know the square root of this? It's an x. Do we know the square root of 9/4? 3/2. Now, couple things. Somebody in here is going, how the heck did you know that so quickly? Turns out you don't even have to think about it. If you calculated out the square root again, that's fine. But we already knew it. This is a number that we squared to get this, right? So if I took the square root of this, I get back to that 3/2 that I already had. I don't have to recalculate it. We've already done it. So I know that this is going to be x and a 3/2. Now, there's not very many times that I'm going to encourage us to think in decimals. It's easier and quicker to check this right now. 3/2 is a decimal. What is it? If you take 1.5 times x, you get 1.5x. If you double it, is it 3x? That is now a perfect square trinomial. That's how we recognize this thing. I know that it's going to get parentheses and a square. Only other thing I need to decide is what's the sign in between them. I'm going to make it a plus. How did you know that? This middle term is a plus. This better be a plus. And that feels like maybe just a hint at like, oh yeah, it has to be this. The real reasoning is that whenever we FOIL this out, I need this to add up to get a positive. That's all I'm ensuring happens. 3/2 plus 3/2. Okay, And that is still equal to what? And we're going to do a little scratch on the side. So I agree with you. This -5 is just -20/4 if we rewrite it as a fraction. We multiply by 4 over 4. And I'm going to add 9/4 to it. This is just a little scratch work. And Seabass, I agree with you. You said -11/4. Okay. Now, at this point, it feels very different than the typical factoring problems. Do you guys agree? Now, it's not. We are still solving, and we did factor just now. This factorization right here from here to here, rather here to here, this is our perfect square trinomial factorization. That's what we just did. Now, what we're actually asked to do. So we were asked to do something by completing the square. Solve. I have an expression or an equation right here that is solvable at this point in time. Unfortunately, everything that I need, the x, right, that's what I'm trying to isolate, it is currently stuck inside of a square right here. It's in parentheses. I can't just subtract 3/2 out. If only there were a way to undo a square. So I'm going to take the square root of the left, but as soon as I think about the square root of the left side of the equation, I better also do what? Square root of the right. Now, I'm going to make a small mistake. I want the first person to see my mistake to shout it out. I'm going to take the square root of both sides. Cool, cool. And I'll do the left side. X plus 3/2 is all that remains because a square undid the square root, or vice versa, equals, what's the square root of -11? Ooh, love it. If you didn't hear Angel, say it louder. We need a plus or minus anytime we introduce the square root of a number, every single time. There should have been one here. I was hoping if nobody shouted it there, we would see it here. Plus or minus the square root of -11/4. Now, we have not gone crazy into the algebra of the radical stuff. We will naturally deal with this. I'm going to make one little note over here. If we take the square root of a fraction, a over b, which is what we have, it just happens to be uglier numbers than a and b, are we allowed to just split this up as a, the square root of a over the square root of b? Yes, this property works. It works with multiplication, it works with division. We can combine or separate if they're multiplying or dividing. Okay, so I'm going to keep this left side still, x plus 3/2. And what I want you guys to do for me, we're going to say plus or minus. I want you to simplify this radical. And I'm going to pause it. I'm going to walk around so that if anybody has trouble with this radical part, we can deal with it. But I need you guys to tell me, not with a calculator. I want like a square root in your answer. Don't want an ugly decimal. What does this square root simplify to? If you have an answer, check with your neighbor, and we'll come back together. I'm going to write this in many more steps than I would normally do it. I recognize -11 is kind of a gross number. Two reasons. One, the negative makes it gross. I'm just going to say that's -1 times what other number? 11. Now, if you write this or don't, it's up to you, but having this thought is really important to being able to solve these problems. Because now as I try to break it down, and I'm going to go one more line, x plus 3/2 equals plus or minus, and let's just think about this in a systematic way. What's the square root of -1? So we're going to, I know it's Monday, just kidding, it's Friday morning, but it's still morning, and it's not even 9 o'clock, just barely 9 o'clock, and it's a math class. We're not all super high energy, I get it. I want everybody to answer that question though. What's the square root of -1? So I had about 60%. What's the square root of -1? Liam, I didn't hear you, so you got to get real loud. What's the square root of -1? I. So I'm going to take the square root of -1, which is what again? I. Anybody know the square root of 11? I have no idea what it is. Can you break down 11 such that it's a square number times something else? So like, what? Can you break down 11 any further? So like when I say that, I mean like 32, and this is just me talking. 32 is 16 times 2, and that's useful because I know the square root of 16, right? Can I break down 11 so that one of its factors is a square? What are the only factors of 11? Okay, so no chance. So I can't do anything with it. It stays root 11. Divided by, harder question, what's the square root of 4? 2. All right, we are so close to being done with this. Now, for this, I'd have to look very closely at your book to see how they handle this. very well might see somebody write this top number. You might see it written like root 11i. I don't like it, just so you know. Can anybody tell me why I don't love this? You have a really good chance of just simply drawing that a little too far and making a mistake. I will always put it toward the front. If you want to keep it in the back end of it, you can. I'm fine with that, but make sure you're very careful about how you draw your radical symbol. Sebastian. Because what's the square root of negative 1? What's the square root of negative 1? It's I. So when I take a square root of something, it comes out, right? Just like if I had 2 times 4 and I took the square root, do you know the square root of either of them? So that's times, I'm sorry. Do you know the square root of either of these? So if I take the square root, it just comes out, right? And what stayed in? Boom. Exact same thing happened here. It's just a negative 1 came out. Okay. All right. So as we look at this, we're one step away from having an exact solution here. What's the very last thing we would need to do? I'm going to subtract 3 halves. Now, if I do it from both sides of the equation, we're always fine. And because I know that complex numbers typically have the form a plus bi, we do that real part first. I'm simply going to, instead of minus 3 halves on the outside, we're going to say it's negative 3 halves plus or minus I root 11 over 2. Now, we are utilizing several different things throughout this problem. We are utilizing the fact that we can find and complete a square here. We're then using the fact that that factors nicely. And then one more, we're using the square root property. We're putting a bunch of different pieces together in hopes of solving a problem that before this we had no chance of solving. Okay, if you checked your calculator, is there any hope that it's going to give you the same answer? There's a 0% chance because your calculator doesn't understand the existence of the imaginary numbers. Okay, your calculator cannot do this. You can do this. Everybody in here is smarter than a calculator. Cool, baller. All right, this problem feels okay, feels awful. Another one together, a little faster, a little slower. Okay, here's the deal. I want you to try starting one. I'll catch up with you guys and jump in. We'll all likely be at different points. Let's do one more similar to this. I'm going to keep this example up as long as I can. I am going to start us off differently, and I'll have you finish it. I just want to look at one variation of this. So let's do one more where I'm going to start us off together because I mentioned there was another way that one might view this problem. So let's look at example B, and I want to solve, let's see here, x squared, I'm cool with that one, x squared plus 10x plus 20 equals 0. Now, before you just start cooking with this, chefs, let's make sure that we hold up and all agree that there's an approach. First thing, GCF. No, bummer. Okay, binomial? Ah, bummer. Trinomial? Ooh, do you know the square root of this? Do you know the square root of this? What's the square root of 20? So whoever said yes, I hope you've changed your mind at this point. Okay, so it's not a perfect square. Bummer. Well, it's a coefficient of 1, which means maybe there's a... So it is a leading coefficient of 1. What am I hoping I can do then? Let's hope we can group with the shortcut, right? So I'm not even going to draw it, but give me the factors of 20 that add up to 10. 5 and 2 multiply to be 10. They need to multiply to be 20. Adds up to 9. Otherwise it works. It's not 1 and 20. It's not 2 and 10. It's not 4 and 5. Yeah, but we can't subtract because then it would give us a negative 20 and it has to be a positive. There's an issue, right? Okay, now, in the previous problem, I just wanted to point out the difference. We just immediately subtracted 5 and then we said complete the square, right? There's another approach. If you don't want to have to move the 5 over and then do it, I'm just going to do a little thinking. If I wanted this to be a perfect square trinomial, the last term, and I'm going to make a note here, the last, or the C term, if we're looking at our quadratic general form, the last term should be something, and I'm going to leave that blank, should be blank for now, if it is a perfect square trinomial. Now, the something part, the question's no different. What's the, I'm going to wait till everybody's done writing before I start talking, I suppose. I'm really curious to see how the audio comes out. I hope it doesn't sound like this the whole time and it's just awful, because that's going to break my heart. But check it out. How do we know what that last term wants to be or should be? You take something over something and do something. You take b, which is what in this problem? 10. You divide it by 2, which would give you, and then you square it. So it should be b over 2 squared, or in this case, I'll write it out. It's 10, that b term, over 2 squared. And you guys just told me it was 25. And I agree with you. Now, we did almost the same thing on this last problem, right? With one exception. We didn't move it first. And that's okay. If I wanted this to be a 25, could we make that happen? I'm going to add 5 where? Both sides of the equal sign. If I know that it's 25 that I need, I'm just going to do this right off the bat. Now, this is weird as far as the annotations, because this is preceding the explanation, but we're going to roll with it. So here we go. If I add 5 to both sides, I get x squared plus 10x plus 25 is now equal to what? 5. And all of a sudden, things are nice again. And if you don't recognize that they're nice, this process where we take this b over 2 and square it, that's called completing the square, right? Which means we've guaranteed a perfect square trinomial, which means it factors so nice, so fast. Sonny?
When you said add it to all sides, no, it's okay. Yeah.
So I don't know exactly where your question is going, but I'm just trying to really stress that if we do something to the left side of the equal sign, we better do the exact same thing to the right.
Oh, it's a little bit different. No, because I was just thinking, like, why don't you add 5 to like 10x and x squared? But
So I kind of did, but they're not like terms, so they can't combine. Seabass? I mean, we could have done that here, but it's much harder to figure out what do I need to add to 5 to get it to be 9/4. It would work, it's just harder to do in that problem. Okay, so they're both valid. Like, we could have immediately started by subtracting 20 and then added 25 to both sides, and we would have still gotten here. Like, this would be our next step. Now, when we look at this, check it out. We don't have to think, because I know, so we kind of have to think. We should always think. But I know that this thing is a perfect square trinomial. Do you guys know the square root of the first and the last? So this thing factors as x plus 5 squared equals, what's on the right side? 5. I want you guys to finish this for me real quick. Once you finish this problem with my assistance, your neighbor's assistance, on your own, check the answer with me, and then I want you to do one more for me, and we'll continue on from there. Then I think we get a sweet word problem to do. So let's see here. Cool. I'm going to move that down a little bit more. Finish B, check with me, then do C. Ye. Do you need to see me do the last couple steps here, or would you like to see me have the last two? I'll take the square root of the left, x plus 5. And when I take the square root of the right on this part B, what has to be there? Plus or minus the square root of 5. And I don't know the square root of 5, so that's cool with me. One step away from solving. What am I going to subtract from both sides? Negative 5. And it always, for whatever reason, it feels more natural to write the radical second, like every time for me. So I will do that constantly. Okay, this one, a little bit different. Not terribly, but we have a choice to make. Do we want to make it a blank that we have to fill in, or do we want to just figure out what we do to both sides to make it be square? You guys prefer the blank? If you don't prefer the blank, that's okay. You're going to get the same answer. Our work's just going to look a little bit different for a minute. Ronaldo.
what happens if you do like the A times the C thing?
Ooh, this one. Factors of positive 3 that add up to negative 2. Can you find them? So it only works to make one of them negative if this happens to be a negative number, because their product has to be positive. So if we made one of them negative before, I guarantee you there was a negative number there. If it's positive, they could both be negative, but that doesn't help us here, because if we use -1 and -3, what do those add up to? Yep, and it still doesn't work. So like we can try to group it, and you should really try to group them, but it doesn't work. Okay, so in this one, if you do not like having the blank spot, your work is going to look a little bit different, but if we get to the same answer, I'm comfortable with it. To make this a blank, what am I going to take away from both sides? Okay, so here's that big awkward space that I'm going to leave, -3. Now, when you're actually doing these, obviously, you're not going to be annotating stuff along the way as you do it, I don't think. When I do these problems, when you do these problems, I might have a little bit of scratch work here off on the side right now to figure out what I need to add, but there's not going to be a whole lot. I'm just going to do it in this very first line. What's B in this problem? So it's, ooh, I heard two different things. What's B right here connected to my x? -2, and I divide it by what number? And then I do what to it? Square it. What's -2 over 2? -1, and now it's squared? A 1. Okay, I'm going to add a 1 here so it's nice and perfect, and I better add a 1 here also. Okay, whether you subtracted the 3 or not, if you didn't subtract the 3, your first move should have been -2 on each side. You still saw it needed to be a 1, and you just recognized, oh, I can make that happen if I subtract 2 here and here. Okay, either way, you wind up at this line immediately. Once we're here, almost all the thought is gone. Like, we've done the hard part, in my opinion. This thing, guaranteed now, because we've completed the square, it's a perfect square trinomial. What are the two pieces that go in here? X, 1, and the sign? Minus. So x minus 1 squared immediately is -2. Michaela, do you have a question? Okay. I can tell you're thinking hard, and I appreciate that. What now? Okay, as always, I'll do the left, x minus 1, and you guys can do the right. What do you want me to write down? Hey, good catch. Plus or minus and the square root of -2. Now, if you jump right to I root 2, I'm cool with it. I'm going to rewrite -2 as -1 times 2, in case it's not super clear how this works every time. Is this still the square root of -2? Yeah. Why would I bother writing it like this? It's easier to do what? What comes out of it? I. Now, in my head is where this normally happens. I recognize if it's a negative and I comes out. But I'm going to do two things. I'm going to rewrite this with the I out front, and I'm going to add 1 in the same step. So here we go. I get a 1, bless you, plus or minus I times the square root of what's left inside? 2. And we're done with it. Okay. These problems allow us for the development of a really handy formula that we will inevitably use. This weekend, I'm going to give you a super duper short homework. Okay. I need you to practice a little tiny bit, but I also want you to have a nice chill weekend, and I want to have a nice chill weekend. And I feel like if I have a chill weekend, you guys deserve it too. You get to do 6 problems. That's it. 6 problems. Do 2 tonight, 2 tomorrow, 2 Sunday, and you're done. And it's like 10 minutes worth of time. So for this, I will put it on the classroom here in a moment, but we get homework 2.5, which you will find waiting for you on page 96. And you have the privilege of working problems 18 through 23. Cool. And I'm actually going to call this 2.5.1. 18 through 23 is all I need from you. Cool, 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 cool. I should have done this earlier. Do you guys have the bell ringers on your desk still? Yeah. Will you hand me, make sure your name is on it, the last 2 weeks that you have? Because I didn't collect them last week because we only had like 2 of them with all the wonkiness. Hand me at least this week. I'm fine with it. Why? Start putting the dates on. I heard my name.